Hello students, welcome. Previously, lesson 10, form 1 to 2, we were dealing with effects of heat on substances, and we have done the heating curve and the cooling curve. So today, lesson 11, we want to proceed to the kinetic theory of matter. Learners, remember during the exam, you can be told state the kinetic theory of matter. So we are saying kinetic theory of matter states that matter is made up of particles which are always in a continuous state of motion. Kinetic theory forms the base of the theoretical model of matter. And we are having here the theoretical model of matter. We are saying solids, particles are closely packed and held in fixed position. The way you see the particles of solid are very close, or they're closely packed. When we go to the other side of liquid, the particles are not closely packed as they are in the solid state, and they have a degree of freedom. They have a degree of freedom, as you can see. We go to gas, we're saying particles of gases are widely separated or apart. They move independently, the way you see. So we go to each state of matter. We start with the solid. So we are going to start solid, and we are saying in the solid state, the particles are closely packed together and can only vibrate within fixed positions. So they do not move from one point to another because there are forces that hold them in these positions. So we are saying the particles of solids are closely packed, and they will not move from one point to another because we have forces, or they have forces that are holding them in those positions. So what will happen when a solid is heated? We have seen that in the heating curve. When a solid is heated, the kinetic energy of the particles increases and they begin to vibrate more vigorously. Like for example, when an ice is heated or when an naphthalene is heated, it increases the kinetic energy, or the heat absorbed increases the kinetic energy of the particles. Therefore, they begin to vibrate more vigorously. That's what you have said. So we proceed, we are saying at a certain temperature, which is fixed for a particular substances, the forces holding the particles are weak enough to allow the particles to change position. As a result, we are told the solid changes into a liquid. This temperature is known as melting point. So what's melting point? Melting point is the point at which solid is being converted to a liquid. So next we are going to proceed to the next state of matter, that is liquids. And we are saying in the liquid state, particles are not as close together as they are in the solid state. They can move from one point to another within the liquid. Remember, we said when we are talking about solid, the particles are first of all close, very close, or they are closely packed together. But when we're talking about the liquid state, they are not so close as they are in the solid state. Next, we said again, if you remember, solids do not move from one point to another because there are forces that hold them in those positions. But when we're talking about liquids, we are told they can move from one point to another within the liquid. And this explains why a liquid has no definite shape and will take the shape of the container. For example, if we're having a cylindrical container and we put water there, so that means that liquid will take the shape of the cylinder. So it will be having cylindrical shape. We're told, however, a liquid has a definite volume. The particles exert some attraction on one another, and these forces of attraction make them, the liquid particles, to stay together. So what will happen when a liquid like water is heated? We are saying when a liquid is heated, the particles move more randomly as the forces of attractions are further weakened. The weakening continues until the particles gain enough energy to overcome the forces between them. At this point, the liquid boils as particles break up or break free and enters the gaseous state or the gaseous phase. So we're talking about something called boiling point. So the boiling point is the point at which liquid is being converted to gas. And we're saying the constant temperature at which a pure liquid boils is known as boiling point, and it is fixed for a particular substance. So we're done with liquid. We're going to go to gas. So we're saying in the gaseous state, the particles are far apart and free to move randomly in all directions. That's why we were saying gases move independently. This is why a gas does not have a definite shape or volume, but occupies the whole space within a container. So what will happen when a gas is cooled? We're saying when a gas is cooled, the particles lose kinetic energy and hence slow down. We have seen this when we are dealing with the cooling curve. So as they slow down, they easily attract their neighboring particles and move close to form a liquid. This process is known as condensation, and we are told condensation occurs at the same temperature as evaporation. Then we are told next, on further cooling of the liquid, the kinetic energy of the particles can continue to decrease, and the particles take up fixed positions as the liquid solidifies. That means as liquids being converted to solid. This process is known as or is called freezing, and freezing occurs at the same temperature as melting. Learners, that's the end of our video today. Thank you for watching.